So this is the last section of chapter 8. We're still talking about planar figures, but now we're going to talk about circles. And there are two things that we have discussed with two-dimensional figures. We've discussed a walk around them, which has been called what? What do we call that with a rectangle? A walk around a rectangle is a perimeter. Good. And then, so we've talked about perimeters. With circles, we don't call it a perimeter. We give it a new name, and it's called circumference. Everyone say it? Circumference. You know that. And then the other topic has been area, because these are two-dimensional figures, right? So we're going to talk about both of these with respect to circles today. Okay? So before I show you this image down here, can you tell me what we call a walk straight across a circle? From one side through the center of the circle, through the center point to the other. What do you call that distance straight across? 3, 2, 1. Say it loud. Diameter. Good. So what about halfway across? If I just walk from the center point to the side of a circle, straight across, we call that a radius. Good. So those are the things that you want to make sure you include in your diagram for the circle. I guess I'll uncover it. There's a third segment crossing this circle here, and you can see it has a label. And what makes a chord different from radius and diameter? We know radius and diameter are related because they both touch something. What do they both touch, Liam? Good, the center point. So a chord is a segment that doesn't have to touch a center point. Although if it does touch a center point, we could give it a name that we've already mentioned. So can somebody tell me what a chord is? Let me give you a hint. A diameter is a chord, but a radius is not a chord. Courtney?
A segment whose endpoints are on the circle.
Good job. Did you read that?
Yeah.
Oh, okay. That sounded like a book. She says a segment whose endpoints are on a circle. So a circle is a figure who has points, which has points, all the same distance from some center point. Every single point on the circle is a radius distance from a center point. A radius is a segment with endpoints on the center and a point on the circle. So a radius is not a chord. A chord has endpoints always on the circle. So you may need to pause and make sure you have these definitions down, you understand them. And is a diameter a chord? Charlie. Does it have endpoints on the circle? Look at this diameter. Does it have endpoints on the circle?
Yes.
Yes, so is it a chord? Yes, it is. Good. There's a new term for 7th grade, and that is central angle. So that's a nice pair of words, central angle. What do you suppose it could mean? An angle in the center, right? So it must have a vertex on what special point? The center point. Good. Okay. So an angle whose vertex is the center. Up here we've labeled the center point C. So you could find a few different angles here. Angle ACB. We have angle ACF. Looks bigger than ACB. And we even have angle BCF. How many degrees are in angle BCF? Who can tell us? Wesley, do you know? Good, 180. It's called a straight angle. Looks like a line, doesn't it? Okay. So central angle is kind of a new term for 7th grade. Let's review how many degrees are in an entire circle. If you were to start at F and travel clear around, the number of degrees is 360. Who's done a 360 on a skateboard? Nobody? Are you kidding me? Nobody here has done a 360? Charlie, I've done a 360. Are you kidding? You guys haven't lived until you've done a 360. Who's done a 360 on a bike, like a BMX bike? That I have not done. How about on like a Razor scooter or something? Have you ever like tried to jump up and spin around and land back on it?
I did that one.
There, okay. So maybe you weren't doing the 360, but the scooter was doing a 360. Okay. No. Just for the record, Bianca has done a 360 on skates. Okay. Circumference. A walk around a circle, right? So we explored this a little bit last week. A walk around a circle. What does circumference equal? You remember? Someone asked, how do you find circumference? And what did I say? There was this group of Greek mathematicians. They explored a lot of stuff. So here's a circle. Did you see that center point when I put the circle down? I haven't seen that before. This is ooh, look at that. There's a center point. You see that? When I make it bigger, it's called dilating it. Have you ever had your eyes dilated?
Yes.
Or constricting, like when you go in the sun. But the center point disappears when I let go of the cursor. Anyway, what these scientists determined, these mathematicians, was if you walk all the way around any circle and just measure that distance, walk around. You could walk around this one. And you walk straight across the circle. They took that and tried some different things. When they walked around the entire circle, they called that the circumference. And when you walk across it, we know that's the diameter, right? And they said, what if we multiply these two? What will we get? Or what if we add these two? What will we get? Or we could subtract them. What other operation could we use? Division. And they found that no matter the size of the circle, every single time they did this, they got this interesting number that goes on and on. And so that's how pi was discovered. What is the date today? My goodness, it's almost Pi Day. It's 3/11 today. So what is Pi Day?
3/14.
March 14th, which is what? Thursday? 11, 12, 13, 14, Thursday. I actually have you guys Thursday, right?
Yeah, for
Pi
2
Day.
hours.
Oh, for 2 hours we could do something special.
We could have pie.
We could have pie.
Apple
Yeah.
pie. Apple pie.
So here we have circumference equals, now look at this, this is interesting. They found that when you divide the circumference by diameter, you keep getting pi. But if we were to say what is circumference, we would have to get d out of there, right? So how do we get d out of there? Multiply by, no. If you want to get circumference alone, you would multiply both sides by, what's circumference
C.
being divided by?
Diameter.
Diameter. So you're going to multiply both sides by diameter. There it is. Circumference equals pi times diameter. Now, we can write that in short symbols. Here's our symbol for pi. A diameter is also equal to how many radius? Radii. One walk straight across equals how many radius, Emily? 2. So often the formula is written that way in terms of radius rather than in diameter. Which way do you think I like to write it?
The first one.
Yes, because it's the shortest one, the first one. C equals pi d. But we know that one walk across equals 2 radiuses. So you can always switch it to radius when you need that. All right? Okay, notice that when they write 2 pi r, they've separated the diameter, which is 2 r's, and they put the 2 over here and the r over there. Can you think of a reason why they might do that? Lauren?
Because you usually multiply 2 times pi.
Okay, we usually do, but why is it that the 2 comes first?
Because 2 radius
is 1 diameter, right? So this equals the above formula, right? These are the equivalent equations. However, 2 is a real number, isn't it? 2? It's a real number. Will it ever change? I mean, next year if we come back, will it still be 2?
Yes.
Yes. So it's the most unchanging thing in this equation. It's a constant. So it comes first. Pi, we have some choices. Pi is what type of a number? Do you remember?
Irrational.
Irrational. You guys are really good at that. So it goes on forever with no pattern, non-terminating. So it's not as constant as 2, which is why it comes second. Now we do have ways of shortening it. We can round it. When we round pi to the hundredths, what do we get?
3.142.
3.14, right? So we can round it there. Often we do, and we stop. Or we could take it further. But it is not as constant as 2, so it comes second. And then radius always depends on the size of the circle, right? So that's the most changing thing. So it comes last. Now, here are a couple of approximations of pi that are commonly used. 3.14. We just stop there because the next number is 1 at the thousandths. And we sometimes use the fraction 22/7, which is not exactly pi, but it's an approximate of pi. Now, we're going to use what we know to find the circumference of a circle with radius 16. Pause the video and come back and check your work. Tell me what the formula is. You're saying 2 pi r because we have been given radius, okay? So now tell me how to substitute. Okay, and 2 times 3.14? 8 times 16 feet. And so we might have to go multiply that somewhere. What do you have for your answer, Wesley? And don't forget your units, feet. Okay, so they did not tell us where to round this number, but they gave us a number to use, which had been rounded to the hundredths. So I think we'll leave our answer to the hundredths as well, because that's what they gave us as their approximation of pi. Okay. Find diameter if c equals 22 feet. So where do we start, Liam?
You have to say C equals pi times diameter
Okay, so why are you choosing this formula this time?
because it's diameter, not radius.
Good, we're looking for diameter, good. Okay, so how would you substitute?
C equals 3.14 times 22.
You're saying C equals 3.14 times 22 feet. Now, were we told that the diameter equals 22 feet? Ooh, so we're going to have to back this up. Okay, so where do we put the 22 feet?
On the other side.
Very good. So we're in 7th grade. Sometimes we are given the actual big total kind of answer. In this case, we're given circumference. So be careful of where you plug it in. What else do we need here, Liam?
Times x
Times, what's this letter here?
diameter.
D, then we put D. Okay, we're looking for D. So how do we find it now? The units would be feet. So this rounds directly to 7 because it's 7.006. Okay, there you go. This shouldn't take you too long. Enjoy your circles here.